Hi everyone, this is Mrs. J, and today we're going to be adding, subtracting, and multiplying polynomials. But first, a quick warm-up, so please pause the video and give it a try. All right, go ahead and check your work. So again, there's lots of different graphs that would meet these characteristics, but the two things to check for, since the leading coefficient is positive, the right side of your graph has to go up, and since the degree is odd, the left side should go down to make it opposite. So mine looks like it goes down, up, down. Yours could just even be like a straight line that is still technically a polynomial function. But as long as the arrows are facing the right direction, you're good to go. Same for part B. The leading coefficient is negative, so the right side has to go down, and since the degree is even, the left side has to match. So as long as both sides are pointing down, also make sure like you don't have any points, because that would be an absolute value graph, not a polynomial graph. So your graph should either be a straight line or curved. All right, so today we're doing a couple different operations with polynomials, and we're going to start with addition and subtraction. Here we're essentially combining like terms. If you have a polynomial plus another polynomial, the parentheses essentially don't do anything for us. I'm just going to rewrite the equation without, or the expression without any parentheses. So now what I'm going to do is I'm going to combine like terms. So first I see I have a 3x cubed and 1x cubed, and I just add up the coefficients to make that 4x cubed. And then I see a 2x squared and a negative 10x squared. So if I add up those coefficients, I get negative 8x squared. And then I do see here that I have just an a solo x term, so that will just remain unchanged. And then last, I have my constants. Negative 7 and 8 gives me 1. So that's it. It's literally just combining like terms. Now, when you're subtracting polynomials like you see in part B, we need to make sure that we're subtracting every single term in the second polynomial, which means we do need to distribute this negative to all four parts, all four terms of my polynomial. And I do like to rewrite the full expression with the distributed negative. So negative 2x cubed minus 6x squared plus x minus 1. And now it's just combining like terms. So I have 8x cubed and negative 2x cubed, which gives me 6x cubed. And then I see negative 3x squared and negative 6x squared, that gives me negative 9x squared. Then we have negative 2x and positive 1x, which gives me negative x. And then my constants, 9 and negative 1, give me positive 8. So just be careful when you're subtracting that you have distributed the negative to every term in the polynomial after the negative. All right, go ahead and pause the video and give this one a try on your own. All right, check your answer here, being careful that you distributed the negative to all three terms in that second polynomial. And then here's our final result. We should also make sure our answer is in standard form, so descending order for the exponents. Okay, now we're going to be multiplying polynomials. So here, there's different ways that people like to kind of organize their work. So I'm going to show you a few different options. One is just kind of that FOIL method, except here we have a binomial times a trinomial. So you're essentially just going to take each term of your first polynomial and multiply it to all of the terms in the second polynomial. I like to draw arrows to show that. So I have 3x times 2x squared. So 3 times 2 is 6. And remember, when we're multiplying terms with exponents, we add up the exponent, so it becomes x cubed. I have 3x times negative 8x, which gives me negative 24x squared. Then I have 3x times 2, which gives us 6x. And then I'm going to go in and do the same thing. I'm going to distribute the negative 5 to all three terms. So I have negative 10x squared, positive 40x, be careful with the negative times the negative, and then minus 10. Then once you've done this, all we need to do is combine like terms. So we only have one x cubed term. Here we have negative 24x squared and negative 10x squared, which gives us negative 34x squared. Then we have 6x plus 40x, so 46x. And then we have our constant, minus 10. Again, we're just making sure our final answer is in that standard form. Now, when we get to the point of a trinomial, so a three-part polynomial times another trinomial, I really recommend this method called the box method. And in fact, you can use it for the previous example. You can even use it for a binomial times a binomial. So since we have a three-part polynomial times a three-part polynomial, I'm going to make a little 3x3 grid like this. And I'm going to list one of my polynomials along the top, separating the terms. And I'm going to list another polynomial along the sides, also separating those terms, but keeping the negatives where they belong. And then in each individual box, I'm simply going to multiply the two intersecting terms. So here we have negative 2x to the fourth, add up the exponents. Here we have negative 1x cubed and 4x squared. Here, we're multiplying these two terms, so negative 10x cubed, negative 5x squared, and 20x. And then last, we have negative 8 times negative 2x squared, so positive 16x squared, positive 8x, and negative 32. So the box method, you're doing the same amount of work. It's just a nice way to kind of keep your work organized, and you're just doing one thing at a time. And when you have polynomials with the same exponents going across, it actually makes it really easy to combine like terms. So if you notice, your x cubed terms are here, your x squared terms are here, and your x terms are here. So when I start to combine like terms, I have negative 10 and negative 1, which gives me negative 11x cubed. I have 16 minus 5, which is 11, plus 4, which is 15, so 15x squared. 8 plus 20, so plus 28x, and then I have my constant at the end. So you don't have to do this, but I'd say when you have a trinomial times a trinomial, you're going to have 9 independent terms to keep track of, and I've just seen a much higher success rate in avoiding small mistakes with the use of this box method. All right, go ahead and pause the video and give this one a try on your own. All right, go ahead and check your work. And again, here I use that box method, but you absolutely are not required to use that method. It just may be something that helps keep your work organized. Okay, we're going to try one more together. Here we have 3 binomials that we are multiplying together. So when you have something like this, you're going to start just by multiplying 2 of them together. It doesn't matter which 2. I'm going to start with the first 2. So when I multiply those 2 together, I get x times x, which is x squared, x times 5, which is 5x, negative 2 times x, which is negative 2x, and negative 2 times 5, which is negative 10. And I still have that last binomial at the end. And then I'm actually going to combine like terms before I go on to multiply in my remaining binomial. And for this, let's try the box method again. This one's a 2 by 3, so I'll do 2 rows and 3 columns. Just to show you it works for any multiplication of polynomials. So we have x cubed, 3x squared, negative 10x, 3x squared, 9x, and negative 30. And then again, it does usually make the combining step a little bit easier. So that leaves us with x cubed plus 6x squared. Remember, we're just adding up the coefficients here. 9 minus 10 is negative 1x. We'll just say negative x, and then our constant, negative 30. There you go. So just be careful when you have more than 2 polynomials that you're multiplying together. Just do 2 at a time, simplify, and then keep going. All right, go ahead and pause the video and give this last one a try on your own. All right, go ahead and check your work. Here I started by multiplying the first 2, and it actually simplified out to just become x squared minus 16. Then I multiplied in my final binomial, and here was my result. You didn't even need to combine like terms. All right, that is all for today's video. Thank you so much for watching.